ninth. Now we have to discuss the subject of the science. In the previous discussions, we have to discuss the chapter we have to discuss right now is motion. So in the previous discussions, we have to see the basic knowledge about the distance displacement. After that, we have to take in the net discussions about the speed and velocities. After that, we have to discuss the average speed and average velocities. Now we have to discuss there are two type of motion. First is uniform motion, and from the uniform motion, what I have to understand here. So we have to discuss uniform motion, uniform and non-uniform motion. Uniform and non-uniform motions. There are two type of motions in which we have to studies here. There are two basic type of motions which we have to including here. The first motion of is uniform motion and the second is non-uniform motions. So we discuss the first uniform. So first we discuss the uniform motion. Uniform motion. So we have to understand what is the uniform motions. Uniform motion is the motion in which the particle covers equal distance in equal interval of time. It means if object cover equal distance in equal interval of time. Equal distance in equal interval of time, then this type of motion is called uniform motions. How we can see that equal distance is equal covered? It means this is the white track, and here we see that this is 1 meter length, this is also 1 meter, here is also 1 meter, here is also 1 meter distance, here is also 1 meter distance, here is also 1 meter distance. We have to take several parts on a straight line. 1 meter, this is also 1 meter, 1 meter and 1 meter. These are all the distances which is representing on the straight line path. So if we see that if this particle is moving from here, if the particle is moving from here, this is our particle and this is moving from here. If this object is covered from here to here and taking a time of 1 second, he covered 1 meter distance. This object covered 1 meter distance in 1 second. After that, we have to see that if this particle is moving from here to here, this also covered 1 second from 1 meter distance. If this particle is moving from here to here, also take 1 second. Also take 1 second. After that, this particle is moving here to here and it covers 1 meter distances, also taking 1 second. After that, this particle is moving from here to here, this is also take 1 second here. After that, we have to see that this particle is moving from here to here and this taking the 1 second time. 1 second's time from here to here when moving from 1 meter distances. Here we concluded that in each interval of time from here to here, from here to here, from here to here, from here, from here. These are the 5 intervals, these are the 5 intervals gaps. And all the gaps are equal separations and this particle covers equal distance, equal interval of a time, then this type of motion is called uniform motions. Here this gap is 1 meter and this covered in 1 second. This gap is 1 meter, this covered in 1 second. This gap is also 1 meter, 1 second, 1 meter, 1 second, 1 meter and 1 second. All the gaps are equals. When the gaps are equal and time taking in this process is also equal, hence we say that this motion is called uniform motion. This motion is called uniform motion. If any particles which is covering on the straight line path, generally it takes a uniform motion. If any particle which is moving on the curvature of the path, generally this does not perform a uniform circular motions. And if we draw a graph like that, this is our x, this is matlab distance, it is distances, and this is the time. If we see the uniform motions, the uniform motion is the motions in which equal interval of gapping should be taken place. So now we see that this is the track of the particle. Here we see that here particle is covered 1 second time in 1 meter, 2 seconds 2 meter, 3 seconds 3 meter, like that from the following observations. And here this type of motion is represented on the graph, and this is called uniform motion. Uniform motions. This x is taken as distance, or we can say displacement, or when the particle is not moving in a straight line, then it is a displacement also taken, and this is the time. Time is always taken in second, and distance is always taken in meter. These graphs which we have to derive the uniform circular motions. Now there are various discussions of motions is also given which is not uniform like that. If we see that this is also a graph, this is x, this is y. If we see a graph of like that, this graph is not a uniform motions, and this graph is called non-uniform motions. Another graph, this is x and this is y. This is also a graph. This is also a non-uniform motion. And here we see that at every instant of time the velocity is changing continuously, and here we see that at every instant of time the velocity of the graph is to be constant, and here the velocity is continuously decreasing or increasing, and here is also continuously decreasing. This is non-uniform motion. Non-uniform motion. Non-uniform motion. So we have to discuss the basic graphs and basic discussions of the uniform motions, and what about the non-uniform motions graph. Non-uniform motion has the velocity will be changing continuously, and in the uniform motions the velocity should be constant.